Welcome to the part 2 of linear algebra. So we'll start with the new subtopic with that is diagonal matrix. Diagonal matrix. So what is diagonal matrix? Let A let A be the matrix of order n is to n. Order n is to n. Okay, means A matrix which is having n row, n column. So this is the first row up to the nth element, and this is nth row, first column to the nth row, nth column element. Okay, now what is diagonal matrix? You can call this matrix a diagonal matrix when the see here, A is said to be a diagonal matrix, if element ij, means ith row, j column is equals to 0 for I is not equal to j, means row and column is not equal. What does it imply? It implies, example, A matrix, suppose a matrix A is there whose elements are 2 3 2 0 0 0 minus 3 4 0 0 4. So see here, this is the diagonal element, and below the diagonal element all elements are 0. So this 0, this is 0, this is 0. So and above elements also 0. So we can call it as a diagonal matrix. Okay, means A is it follow element I j is equals to 0, means I row j column element is 0. So this is, suppose this element we can call it first row, second column. Okay, so it is 0 element. This element we can name it as first row, third column. So means aij is 0 where I is not equal to j, means only diagonal elements will be present and any all other elements will be 0. So we can call it as a diagonal element. We can also write is diagonal element 2 minus 3 4. So these 2 minus 3 and 4 are diagonal element. Okay, and usually we denote diagonal matrices as capital letter D. So usually diagonal matrices are denoted by letter capital D, and it is written like capital D is equals to diagonal element d1 comma d2 comma dn element. So we can write like this also, diagonal elements. One note point is here. Suppose diagonal elements power is k, so each element will pose a power of k. So d1 element will have power k, d2 element will have power k, up to dn power dn element will be have power k. So suppose you write d square, means all diagonal element have got the square power, so all the diagonal element will become, so this will, suppose you write d square here, from this you write d square here, so all element will get the square, 2 square minus 3 whole square 4 square, okay, 2 square minus 3 square 4 square, so you'll get 4 4 9 16, this diagonal element. Okay, clear? Suppose you wrote d cube, so all the diagonal element will be d cube, means 2 cube minus 3 cube 4 cube, so you can write it 8 minus 27 64. So clear to you? Now we'll see upper triangular matrix. Now we're going to see upper triangular matrix. Now we are seeing upper triangular matrix. So suppose matrix A, which is order n, let A be a matrix of order n. First row, first column, first row, second column element dash 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 dash. Second row, first column, second row, second column up to n. Take, okay, and all other elements are 0. Okay, so that is Aij is 0 for I is greater than j. This is the condition of upper triangular matrix. Means upper triangular matrices, see example, this is the example of upper triangular matrix. So this is element 1 4 5 0 7 8 and 0 6 0 0 0 0 0 6. So this is the diagonal element, and above the below the diagonal elements all elements are 0. Okay, so this is the upper triangular matrix, means below the diagonal elements all elements will be 0. So this is the example of upper triangular matrix. Similarly, you can guess what will be the lower triangular matrix. What will be the lower triangular matrix? All elements above the diagonal element will be 0. So here all elements will be 0. This is suppose n cross n matrix. So that is element ij is 0 for all I is less than j. I is column, j is, sorry, I is row, j is column. So example of lower triangular matrix, suppose this is the matrix A, and all whose elements are 1 0 2 0 0 4 5 0 and 7 8 5. So this is the diagonal element, and all other element above the diagonal is 0. So 0 0 0. Okay, so this is the lower triangular matrices. Okay, clear? Now we are going to see the inverse of matrix. Inverse of matrix. Okay, so we will start with some properties, then we'll see the inverse of matrix. So first property is determinant of A is 0. If determinant of A is 0, then we call it is a singular matrix. This is called singular matrix. This then matrix A is called singular matrix if determinant is 0, is called singular matrix if determinant of matrix A is 0. If determinant of A matrix is not 0, then we call it is non-singular matrix. Then A is called non-singular matrix. You will see in further lecture how we will calculate determinant. Don't worry. Okay. Now second property is if inverse of A exist, then determinant of A will not be equal to 0. Okay, this is the vice versa. Then third property is if AB matrix is equals to BA matrix is equals to I, then B is called transverse of A and denoted by B is called transverse of A and denoted by B is equals to A inverse. Okay, that is if A matrix multiplied with inverse of A and inverse of A matrix multiplied with matrix A, then we got I. Okay, this is the third property. Now fourth property is how we calculate inverse of A. So inverse of A matrix will be adjoint of A divided by determinant of A. This is important one. You remember this formula. So inverse of A is adjoint of A divided by determinant of A. So how we calculate adjoint of A? We calculate adjoint of a cofactor matrix transpose. Cofactor matrix transverse. We will transverse it. Okay. So suppose you want suppose one example, see here. This matrix A, you want to calculate you want to calculate inverse of matrix A. So element of matrix A is 1 2 4 2 1 2 1 minus 1 3. So you want to calculate inverse of A. So how you will calculate? So inverse of A formula is adjoint of A divided by det of A. By using this formula you will calculate inverse of A. So first we calculate determinant of A. So how you calculate determinant of A? You write first element here and hide this row and this column and write remaining elements. These remaining element you write. So you write here 1 2 minus 1 3. Okay. Now so here it is plus. Now write minus and you write sorry here it is 3. Okay, so you write this element with minus sign and hide this row and this column and write remaining element. So remaining element is 2 2 1 3. Okay, then write plus sign and write this element 4 and hide this row this column and write remaining element 2 2 1 1 minus 1. Okay, now you calculate determinant of A. This is 1 and multiply this element and write 3 3 into 1 3 and multiply these two element diagonally. So you will write minus sign, then 2 into minus 1 is minus 2. Okay, then write minus 3. Similarly you multiply these two element, that is 2 into 3 minus sign, multiply these two element 1 into 2, then plus sign 4, you multiply this element to this element 2 into minus 1 minus sign this element to this element 1 into 1 and you calculate. So you are getting here 5, 3 minus minus plus plus 2 means 5, then minus 3 into 6 minus 2 plus 4 minus 2 minus 1. So this is 5 into 3 into 4 plus 4 minus 3. So 5 minus 12 minus 12. So you are getting minus 19. So determinant of A is minus 19. You are getting from here. Okay. So this is how we calculate determinant. Now talking about the cofactor. How you calculate cofactor? Cofactor matrix. So first you write this plus 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 and remaining minus minus sorry minus here here and here. Okay, so all diagonal will be plus and remaining will be minus. Okay, clear? So how you calculate matrix cofactor matrix? Okay, so see here, you just write like that, plus sign minus sign plus sign minus sign plus sign minus sign plus sign minus minus sign plus sign. And now you see how you calculate cofactor matrix. Suppose I am writing here the matrix A, which is given 1 3 4 and 2 1 2 1 minus 1 3. So this matrix is given. Now we are calculating from this matrix to cofactor matrix. Okay, so how you calculate? You're here. Okay, so you hide this row, this column, right? Remaining elements. So this is 1 2 minus 1 3. Okay, now you are here, you are here, now you are here. So you hide from here this row, this column, right? Remaining element. So remaining element is 2 2 1 3. Now you are here. So hide this row, this column, and write remaining element 2 1 1 minus 1. Okay, minus 1 here. This is minus 1. Now you are here. So hide this element, this column, this row, this column. Okay, so write remaining element 3 4 minus 1 3. Similarly, you are here. You hide this row, this column, this column, this row, and write remaining element 1 4 1 3. Okay, you understood the pattern how I am calculating. Okay, now you follow this pattern. So I am just writing all elements. Okay, so after calculation you will get 3 this. Okay, now just multiply this element to this element. Minus 1 into 3 minus 1 into 2. Okay, similarly 2 into 3 minus 1 into 2 is 2 into 3 minus 1 into 2. In this way you calculate add. Okay, now you write after calculation you will get cofactor matrix plus 5 minus 4 minus 3 minus 13 minus 1 plus 4 2 plus 6 minus 5. So this is cofactor matrix. Okay, this is cofactor matrix. This is cofactor matrix. Now you transpose the cofactor matrix. Transpose means you make the row to this row to the column. First row do you convert this first row to the first column means in this way. Okay, so you write convert it into column. This is 4 minus 5 plus 5 minus 4 minus 3. This row to the second column minus 13 minus 1 4. This row to the column 2 6 minus 5. So you have converted into transpose. Now you just multiply. So what is the formula of A inverse? The formula of A inverse is adjoint of A by det of A. So after transposing you got the adjoint of A. After transpose you got adjoint of A. You just multiply with the 1 by determinant. You will get the A inverse. So A inverse will be A into det of A. Det of A we got 1 minus 19. We already got determinant of A, and just write adjoint of A. So adjoint of A we already got, so just write it here. So this is the A inverse. Okay, this is how we calculate A inverse. This is how we calculate inverse. So you just calculate adjoint of A, then multiply it 1 by determinant. You will get the adjoint of A. So I will repeat once again quickly here. If you want to calculate the inverse of this matrix, you just calculate determinant. So I have calculated the determinant here. I got minus 19, and what I did, I just wrote the sign. These diagonal elements will be plus, okay, and I just hide this row and this column. I got this one. Similarly I followed this pattern, so I got cofactor matrix. You transpose cofactor matrix into if you transfer cofactor matrix, then you will get adjoint of A. So how you transpose means you make first row to first column, second row to convert it to second column, third row convert it into third column. This is how you get transpose. So you got the adjoint of A. So A inverse means adjoint of A divided by det of A, determinant of A. So you will get A inverse. In next lecture we'll see the shortcut how you calculate determinant and inverse. Okay, till we will see you in the next lecture.